All right, so we're doing 3.2. We're talking about rate of change and slope. So I can find the rate of change or a slope. So rate of change is a ratio of the amount of change in the dependent variable or output to the amount of change in the independent variable or the input. But guess what? That's this same ratio, y over x. So it's still our constant that we're trying to find. We're just giving it a term of rate of change. It's the rate in which the information changes. Now, another term for rate of change, a more general term in case we don't have actual units, we would just call it the slope. So a slope of a line is the ratio of the change in the y values, which we call the rise, compared to the change in the x values, which we call the run. And then it's this equation. We're going to take our y's and subtract them, and we're going to take our x's and subtract them. That's what change is, right? So if you notice, though, it's still the same ratio, y's over x's. We're just going to find it a little bit different. So before, right, we just put y over x. Now we're going to subtract and get still y over x or rise over run. And we call this like this, rise over our run. All right, so we have Eve, who keeps a record of the number of lawns she has mowed and the money she has earned. Tell whether the rates of change are constant or variable. So we can actually do this two different ways. We can do it the way we've been doing it, which is just y's over x's. But the best way to do it is actually to check with using our y1 and y2s and subtracting. That's actually the best way to do it. So we could do 15 over 1 and 45 over 3, which is 15, and 90 over 6, just checking, yeah, which would be 15, and then 120 over 8, so that is 1, 4 left over 40, which is 15. We also can check it using our slope formula. So what it just says is, right, remember this one x and this one y. We just need to subtract two of the points and check that they, and two of the other points and check that they equal the same thing. So we can subtract here and subtract here. So here's what I'm going to do. I'm going to do it over here. I'm going to take, remember, y over x. I'm going to take this one. This is what we're going to call our first point. I'm going to go 45 minus 15. I'm going to put it over 3 minus 1. So right here, these points go together. So these points go together. And these points go together. And these points go together. So 45 minus 15, that's 0, and that's 3. And then we get 2. And we reduce that, and we get 15. That's a good sign. So then let's do these two. So I'm going to go 120 minus 90, remember y's over x's, 8 minus 6. Well, 0 take away 0 is 0, and 12 take away 9 is 3, and 8 take away 6 is 2, and look, we get 15 again. So that's a really good sign. You actually can subtract any points you want. They don't have to be next to each other. I could have moved all the way from 8 to 1. So I'm going to show you that as well. Watch, I'm going to go 120 minus 15 over 8 minus 1. So I have to borrow. 10 minus 5 is 5. 1 minus 1 is 0, and then we have 1 left over. And then 8 take away 1 is 7. So if we divide, 10 goes into, or 7 goes into 10 one time, 3 left over, and 35 divided by 7 is in fact 15. So notice you can take them from any 2 points that you want. So now what we're going to do is it says find m, the slope of the line. So the letter m is the slope. So let's actually go back to our first, up here to your vocab. We write the letter m in here as well. Anytime you see this m, it actually means slope. So same idea with the table. We are going to take two of these points. I want to practice using this formula, and we're going to find the slope. So let's take any 2 points. I'm going to take 345 and 115. And so I'm going to do 45. I actually already did this, 15, right up above. And then I'm going to take 3 minus 1. So I get 30 over 2, which is 15. So I would say the slope, or m, is equal to 15. Remember, you can take any 2 points I want on this. It doesn't matter. I proved it here 1, 2, 3 times, and I still got 15. So you can find this rate of change by just subtracting. Okay? All right, so we're going to be given a table. The table shows the approximate height of a football after it kicked. Tell whether the rates of change are constant or variable. First it says find the rates of change. So rates of change is how much the x's and the y's change. So we technically need to find this subtraction, right? We're going to subtract, subtract, subtract. So if I take away 26 minus 31, that's actually a negative, right? 26 take away 31 would be minus this way. Those are 5 apart, so it's negative 5. And if I subtract this way, I get a half. So this rate of change is negative 5 over a half, which is like negative 10. Just so you know. It's about negative 10. Isn't about, it is, if you actually divide these. So then, if we do it again, if I'm going to subtract from here to here, well, 31 take away 18, first of all, is positive. It's 13. All right, this is 13. And if I subtract here to here, I actually get 1. So this rate of change is 13 over 1, which is 13. That's different. So I've gotten negative 10, I've gotten 13, I have technically one more to find. This is 18 take away 0 is 18, and a half take away 0 is a half. So now we have 18 over a half. And if we divide 18 by a half, it's actually 36. So these are all of our different rates. See how they're all different? Because they're all different, this is what we call variable. Variables are things that change, they're not constant. So that's how you find your rate of change in your table. All right, so let's do a graph again. So it says the graph shows the rate at which water is leaking from a tank. The slope of the line gives the leaking rate in gallons per minute. Find the slope of the line. So they notice they broke it down for us. They want us to first find the rise, which would be our change in y's. So there's actually another way besides subtracting on a graph. And now it only works on a graph that you can find the rise and the run. You can actually just count. So I'm going to go from this dot to this dot. I'm going to count how many times do I need to rise to be level. So I'm going to go, well, this is at 3. So 1, 2, 3. So I went up 3, and since I went up, it's a positive 3. And then I'm going to run. So I'm going to go 1, 2, 3, 4. I ran 4. And because I went to the right, it's positive. So these points were at 4, 3, and 8, 6. Just so we see that. So once we have our rise and our run, remember slope is just rise over run. So I'm just going to make a ratio of these, 3 over 4, and we're done. So there's 2 ways. You can now just count, kind of like I did here. I just counted how far apart they were. Or you can use the formula. So I'm going to actually show you that the formula works too. I'm going to take this point and I'm going to subtract this point. I'm going to go 6 minus 3. Those are my y's. See, y's, over 8 minus 4, those are my x's, and we get 3 over 4. So you can see it's the same thing. So things to remember, use the slope formula to find the slope between 2 points. That's that y minus y, right? It was y2 minus y1 over x2 minus x1. When the rate of change of a relationship is constant, it creates a straight line, same slope between any 2 points on the line. So that's why it becomes constant, because the slope from one point to the next is the same. And so that's what creates a straight line. So anytime you have a straight line, you're gonna have a constant slope or rate of change. All right, so first one, you have a table. You need to tell me if this rate of change is constant or variable, okay? And then find the slope of this line. You can either find 2 points and find them, or you can just count. So there's a point here. There's a point here. I'm gonna find you a point way up here. And there's one right here. So there's some points for you. So you can either count between them, or you can use a slope formula. All right, until next time.